Welcome to Hartman Math. This is lesson 3-1, our introduction to cubic functions. F of x equals x to the third power. Whenever we're trying to get an idea of what a new function looks like in terms of its graph, we like to do a table of values. In general, we like to try some positive values, some negative values, see how that goes. So real f of -2, think of it in terms of inside parentheses, to the third power, meaning -2 times -2 times another -2, we would get -8. So we have a point at -2, comma -8. -1 to the third power, -1 times -1 times -1 is -1. So left one, down one. 0 to the third power is, of course, 0. So we do have a point at the origin. 1 to the third power is 1. 1 comma 1. And 2 to the third power is 8. So 2 comma 8. So in terms of shape, it's not a parabola, as we're in quadrants 3 and 1 for our parent function here. To draw the curve, it's a little bit challenging to do because what you have to look at, what we're looking at as teachers, is as we go through to the right, as we keep moving to the right, it keeps moving to the right. So we never want to go straight up the page. So that's one challenge. And the bend is the other challenge. We're going to see in this part, it's bending this direction. So it's called concave down. And then it changes the direction of the bend here at the origin, which you're going to see, we're going to call that an inflection point, and it's going to change now to bending the other way, concave up. So it's concave up. So when we hit here, we can't bend this way because it doesn't do that. And it doesn't ever go straight up or bend back on itself. It's got to keep going right, because we're going to see what that means in terms of domain and range and things like that. Speaking of, let's take a look at some key characteristics of our cubic function. What is the domain? According to the graph arrow, we're wondering how left and how right, what x's can we plug in? We can take any real number, positives or negatives, and cube it. So the domain is from -infinity to positive infinity. The arrow is pointing left forever, that one's pointing right. Mainly up and down, but we've got to think left and right for our domain. And it's going to keep going left, left, left. The range, how low does it go? How high does it go? That one's also -infinity to positive infinity. And the nice thing about cubic functions, that's going to be true for every cubic function that we look at, that we graph. All right, where are we increasing? Where is our graph going up as we trace from left to right? It's always going up. So increasing would be from -infinity to positive infinity. It's increasing the entire time. So when is it decreasing? Well, if it's increasing the entire time, it can't ever be decreasing. When are we going down? Remember, we must be going from left to right. We're never going down. So there's no interval. Where are we positive? Above. This is our section above. Starting at 0, going right forever, 0 to infinity. Negative. Where are we below? Where do we have negative function values? Starting at -infinity until we get to 0. Remember, these are domain intervals. Left to right, these are x's. What's our end behavior? As x approaches infinity, as we go right, right, right on the graph, our function is going towards positive infinity. As x approaches -infinity, as we go left, left, left on the graph, where is our function going? -infinity. And where's our inflection point? Where did it change the bend from concave up to concave down, or vice versa? It was bending this way until we hit our center point. I kind of like to say center point, but it's an inflection point. Then it changes and bends the other way. So in this case, for our parent function here. The origin is our inflection point, where it changes the way it bends. So we've taken a look at f of x equals x to the third power. What if we slightly manipulate our function and do maybe 1/2 times x to the third power? Well, 1/2 times, well, x to the third power is giving us our y coordinates. So we're saying 1/2 times each of the y coordinates. So let's just go point by point. The x coordinate remains constant. When x is 2, the y coordinate was 8, but now we multiply that by 1/2. 1/2 times 8 is 4. So there's a new point. When x is 2, the new y coordinate is 4. Let's go to this one. When the x coordinate is 1, the new y coordinate, well, it was 1, multiplied by 1/2 is now 1/2. So it's right there. About here, y coordinate is 0. Multiply that by 1/2. Still 0. So that point did not move. When x is -1, the y coordinate here is -1. Multiply the y coordinate by 1/2, you get -1/2. And our last key point, which was when x is -2, the y coordinate is -8. That was our y coordinate right there. 1/2 times that -8 is -4. So when x is -2, the new y coordinate is -4. And we can draw the graph. So this is our a value, same as it was back in Unit 2 for quadratic functions, that multiplier in front. A was 1/2. What was the change in the graph? We can think of it getting a little wider, but really what's happening is it's a vertical compression. We took all of our points and smashed them towards the middle of the graph, towards the x-axis. So we compressed all of our points. This one went this way. So they're all half as far away from the x-axis as they were. So we call that a vertical compression. All right, let's look at another one. H of x, -x. Back to the x to the third being our red graph, -x to the third. In this case, negative is a transformation. It's a reflection. It's happening outside of the function. The function is x to the third. It's happening outside of the function. And it's going to reflect across the x-axis. So it's going to take our red points and flip them across the x-axis. So we went from +8 to -8. We go from +1 to -1. We're going to go from 0. Oh, that's actually on the x-axis. So it stays on the x-axis at 0. We went from -1, flip it across to +1. From -8, flip it across there. So here's our graph. A was -1. What was the change in the graph? We took our graph and we reflected it, or flipped it. But the technical word there was we reflected it across the x-axis. So that's a reflection. Example number 1. Graph g of x equals x minus 2 to the third power. I've already got 3 key points for the base graph, our original cubic function, x to the third power. 0, 0, 1, 1, -1, -1. I didn't show the 2, 8 because it doesn't fit necessarily on this graph. So when we start to do these transformations, especially when we do these vertical compressions or stretches, sometimes the points can really get spread out. So we're going to focus on the 3 central points. The inflection point, 1 to the right and 1 to the left. Focus on 3 key points, but we have to make sure we have excellent shape on our graph. Notice the shape starts here. I kind of like to do it, just want to draw this curve, and then start here, draw this curve. It's our base graph, so we're going to draw it dotted. All right, so we're going to think, what's happening? Well, here's our transformations. A, anything in front, is a vertical stretch. Or we saw in the previous one, it could be a compression. And or we saw previously that A in front, if it was negative, causes us to reflect across or over the x-axis. The H and the K give us shift. H, because it's with the x, is left and right. K is up and down. Like we saw back in Unit 2 with vertex form for our parabolas inside the parentheses. We're going to want to think opposite because it is that form x minus h. So think opposite to get your h. So here we go. Do we have any a value here? No, a is 1, so no worries there. We can go right to our hk shift. Nothing out here. I think k is 0. So what's our shift here? H is going to be 2. Think opposite. That's going to mean we're going to shift right 2. So we're going to take our 3 key points and drag them all 2 spaces to the right on the graph. And then we just got to draw the nice shape. So from here, drawing bending up, and this one bending down. That's our shape. Cannot be straight. They're not straight. They're curved. Can't go straight up the page. Can't go straight down the page. Still moves to the right without bending the other way. Get used to it. Example number 2, a little bit more complicated on this one. When we have multiple transformations to do, here's our order. Reflect first, then stretch, or maybe compress. Those are interchangeable though. We could do the stretch first and then the reflect. We could combine them. We'll see that in a second. And shift last. We always shift last. So we're dealing with an x cubed graph. So here again are our standard points for our parent function, our base graph. -1, -1, 0, 0, 1, 1. We see the shape and it is dotted. So the first thing is we're going to take care of the A. So if we were going to go in order, we would flip everything across the axis. So we go here. Point on stays. Flips across to here. Bend. Bend. That would be the negative. Then stretch. So now when we stretch, we are multiplying by 2. So we're multiplying y coordinates by 2. The y coordinate here is -1. We multiply by 2. It's now -2, which means we don't go down 2. It just means that's the new y coordinate. So it gets placed right here. 0 multiplied by 2 is still 0. Stays there. +1 for the y coordinate gets multiplied by 2. It's now +2. The new y coordinate is +2. We can actually combine those two steps by just multiplying y coordinates by -2. So if we did that, what we would say is +1 multiplied by -2 is -2. The new y coordinate, when x is 1, stay on the same vertical line, is now at -2. 0 multiplied by -2, still 0. -1 as a y coordinate multiplied by -2 is +2. Now, draw the shape. It's got to bend this way. That one's got to bend that way. And then the last thing we do is shift. We can do those both at the same time. So how is this going to shift? 3 units which way? Think about it for a moment. It's inside parentheses. It's with the x. X is left, right. Think opposite. Go left 3. What about the +1 at the end? That's not with the x. So that's up, down. What you see is what you get. That's going to be up 1. So we're going to take our 3 points that have already been reflected and stretched. So the blue graph here, we're going to go left 3, up 1. So left 3, up 1. Same thing here, same thing there. Left 3, up 1 with all of our points. Redraw the curve. here's one. It's your turn. So pause the video here until you're ready to take a look, match your graph to what we come up with here for our function k of x. All right, we're going to take a look and do the a first. So that's reflect or stretch. It's not negative, so there's no reflect. It's just a stretch, but asterisk meaning we're really not stretching this one since we're multiplying by a half, which is a number between 0 and 1. It's actually going to compress. So our points are going to get closer. So let's actually do that multiplication. So 1 times a half is a half. 0 times a half, still 0. Negative 1 times a half is negative a half. There's our graph. What about this? Transformation. What shift does the minus 4 do? We're going to move 4 units which way? It's not inside the parentheses with the x, so it's not left, right. Outside the function, what you see is what you get. We're going to go down 4. So down 4 with all of our points. Redraw the curve. And we got it. Last thing we're going to look at is what if we have an existing graph of a cubic function and we need to come back to writing that function. Let's start with the inflection point. Where are we changing from bending this way, concave down, to bending concave up? Essentially, what's our center point? The center point's right there, 4, 2. That gives us h and k. H is 4, k is 2. Now, how do we get the a? It's going to be kind of similar to when we were doing this with parabolas back in Unit 2, is we would start at the vertex. Now we're starting at the center point. We'd move right 1. We're going to do the same thing. Right 1. And then how do we get from there to that next point vertically? We're going to have to go down a half. Down means negative. So a is going to be negative a half. So we just take our a, h, and k, plug them in here. I will tell you it's a very common mistake to leave off the exponent. The exponent gives it the curved shape. Can't leave off the exponent. So we've got f of x. You can actually use any name you want to. K of x, whatever. F of x is equal to negative 1/2, parentheses x minus 4, close parentheses cubed, plus 2 is our function. Let's try one of those on your own. It is your turn. Pause when you've got, until you've got your answer. All right, our inflection point, it was bending concave down, now it's bending concave up, is right here at negative 2, negative 1. That means h is negative 2 and k is negative 1. A. What is A? Here's our inflection point, our center point. Right 1. How do we get to the other point? 1, 2, 3 going up. A is positive 3. Here we go. 3. X minus negative 2 minus will definitely turn into plus 2. Cubed, don't forget your exponent, minus 1 from the k, f of x equals, it's a function. And that's it for today. I'll see you next time.